Good evening, students.
Good evening, sir.
So last class we will discuss about the hydrocarbons. Okay. Today also we will continue the same. So when we saw that method of preparation from alkyl halide, we have started the reduction of alkyl halide. When you reduce that alkyl halide by using zinc copper couple, sodium ethanol, zinc HCl, zinc acetic acid, palladium or platinum, nickel nitrogen, aluminum mercury alloy, lithium aluminum hydride, you can able to get the hydrocarbons. Okay. Same way. Next, we are seeing the Woods reaction. The Woods reaction will be Woods-Fittig and Woods. Okay. So you can prepare when you are taken the alkyl bromide or alkyl iodide in presence of the sodium metal. So 2 moles of sodium bromide, 2 moles of alkyl bromide in presence of sodium when you are heating in presence of dry ether. Ether is a solvent. Since sodium metal you have involved, you should not use the protonated solvent. You have to use the solvent like ether, okay, benzene like that. When you are using that, so that RBr plus Na and Na, 2 moles of Na and then RBr. So what will happen? It will take this and then it will take this. So ultimately it will give RBr, sorry, RR plus 2NaBr. For example, when you are taken ethyl bromide CH3 CH2Br plus Na plus CH2 3 CH2Br, same ether and then heating, it will take that you have to use 2 moles, then it will leave that 2 NaBr, then it will give the N-butane as a product. This is the way you can prepare. By this method, you cannot prepare the methane. Okay. So you can prepare, you will get the symmetrical alkane. Symmetrical alkane means when you are dividing 2 parts, it will become same. So when you are dividing here, it will give the 2 equal part. That's symmetrical. Okay. It contains double number of the carbon present in the alkyl chain. Look here, you have 2 carbon, then here you have the 4 carbon. That is the application, synthetic application of this method. Suppose in case if you are using ethyl bromide plus methyl bromide sodium iodide, then you can get number of product because this will undergo self coupling, it will give ethane, and then these two and this one will couple, it will give CH3 CH2 CH3 butane, And then this will undergo self-coupling. It will give CH3, CH2, CH2, CH3. So we will get a different number of product when we are using two different alkyl bromide. So what will happen? You will get the 1, 2, 3, three types of product. You will get it. So the separation of this alkane is not that much easy because their difference will be very less, no, because it is homologous series. It will vary with the CH2, only one CH2 only vary. So the separation will be very, very difficult. So and then this is the drawback of this Woods reaction. And then when you are using tertiary halide, CH3, 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 Br, tertiary alkyl bromide, in the presence of sodium, what will happen? It will give the alkene. Instead of you may expect that you will get the alkane. Instead of that, you will get the alkene. So this is the main drawback of the reaction. Suppose in case in your reaction, in this reaction, you have the moisture. So what will happen? Sodium will react with the water. It gives sodium hydroxide. Okay, that sodium hydroxide, when you are using RX, it will give the alcohol. So instead of alkane, you will get the alcohol also. This is the main drawback of this reaction. And then you can prepare from the carboxylic acid. From carboxylic acid. So two methods. One will be from decarboxylation. So decarboxylation means you have to remove that removal of CO2, COOH, so that you can remove as a CO2 gas. Okay. So when you are having CH3, COOONA, sodium acetate, in presence of sodium hydroxide. Okay. So this will be removed as a CH4 plus Na2CO3. You will get the methane. So how this reaction is happening? So you are taking CH3, mechanism of the reaction, COOOH. When you are using sodium hydroxide, you have the hydroxyl ion. No, this hydroxyl ion will take the H plus. So it gives like this. Due to this, it will open up this ring and again it will close and it will go like this. So it gives CH3 minus and CO2 plus H2O. When you are having H plus, it will become CH4. This is the mechanism. Are you able to understand the mechanism? So again, நான் சொல்ற பாருங்க, you are taken the base, right? Then the base will take the H plus ion. H plus ion. So now O minus ஆகும். O minus இங்க வருது. வரும்போது இது open ஆகும். O minus. Again the O minus close ஆகும். Then it will remove as a CH3 minus. எங்க வந்து arrow mark போகுதோ அங்க minus. CH3 minus. Then it will give CO2 plus H2O. The CH minus, when you are adding plus H plus, you will get the alkane. So this is the, இனி வந்து after plus 2 also, till plus 2, this is the mechanism of decarboxylation reaction. So another method, important method is Gold's electrolysis. This is very costly method, but you can prepare alkanes. So same way, you are taking CH3, COONA, sodium acetate, so plus water in electrolysis. Electrolysis means you have the anode and cathode. So what will happen after the reaction? It yield CH3, CH3, plus 2CO2 plus 2NaOH plus hydrogen gas. Okay. Now this CH3 ethane, you will get at the anode. At anode, you will get the sodium hydroxide no at cathode. Here also they are using 2 moles of it. So 2 moles of water, right? இப்படி எழுதிக்கலாம் HOH HOH இப்படிதான் இருக்கும். So now we have to do the mechanism. All the reaction we have to do the mechanism. Mechanism is nothing but the movement of electrons, okay, in each and every step. So by this method methane cannot prepare because you have to take twice. The methane is only 1 carbon, no? So that you cannot prepare the methane. So the side products here you will get the side product as a olefin and alcohol. So because of the alkaline solution, your the sodium hydroxide is one of the product, no, and ester also you will get because you are getting alcohol is a product, olefin is a product, then the alcohol and corresponding acid react in presence of base, it will give the ester. So the presence of alkyl group in alpha position decreases the yield of alkanes. So the mechanism of the reaction is first CH3, this is the reaction 2CH3COONA, then 2H2O, it gives CH3CH3 plus 2CO2 plus 2NaOH plus H2. This is the reaction. When you are taking the mechanism, CH3COONA, when you are ionization, it gives 2CH3COO minus plus 2Na plus. So what will happen at anode? Two CH3COO minus, it will become, because the anion, no, that anion become 2CH3COO dot. So at anode oxidation takes place. So loss of electron is oxidation. 2 electron it will lose. So the 2CH3COO dot, it will become 2CH3 plus dot plus 2CO2. So when you have the CH3 dot plus CH3 dot, when it combine, it will give CH3 hyphen CH3. It becomes C2H6. And then at cathode, what will happen? When you have 2H plus, you are adding 2 electron, it will give 2 hydrogen atom. When it combine, it will give the hydrogen gas. This is what happening. This is the mechanism. When you have CH3COO Na2NaOH, so this reaction will take place. When first it ionizes the acetate and sodium plus, that acetate will converted into radical when it lose the electron. That acetate radical, it leaves the carbon dioxide as a molecule and then 2-methyl radical. The 2-methyl radical combine, it will give the ethane. At cathode, when the 2 hydrogen atom attract the 2 electron, it will give the. This is the mechanism. And then loss from Grignard reagent. What is Grignard reagent? So the Grignard reagent have the multiple application. So when you have the alkyl halide, you are treated with the magnesium, it will give RMGX. So this RMGX is nothing but when you are taking the methyl chloride CH3Cl, become delta plus, it become delta minus. When you are treated with magnesium, it becomes CH3MgCl. Now the CH3 become negative, this Mg become positive 2 plus and Cl become negative. So that CH3 plus you convert into CH3 minus. So the cationic part of the methyl converted into anionic part. This is the success of the Grignard reagent. This Grignard reagent can react with any other things. You can prepare alcohol, acid, ester, aldehyde, any type of homologous series. If you want to prepare by the Grignard reaction, you can prepare. Okay, that is the reason why you got the Nobel Prize also. So, example for that, you take that ethyl methyl magnesium iodide. When you treat with the water, it will give CH4 plus MgOH and I. When we are increasing the alkyl chain, CH3, CH2, MgBr plus water, you can have CH3, CH2, CH, CH3 plus MgOHI. Okay. Same way, when you have RC triple bond CH. When you have acetylene, this hydrogen is very acidic. Okay. So when you are treated C2H5MgI, so this hydrogen get replaced into C2H6 plus MgC triple bond Cr plus I. So like that, the reaction will go. Same way that CH3 MgI, you have when you are reacting with deuterated water, D2O. Instead of hydrogen, you have D2O. So heavy water, it will give RD, deuterated alkane plus deuterated magnesium hydroxide and then halide. So this is the method of preparation of alkanes. So when you are going for the physical properties of alkane, so the physical state alkanes are colorless and odorless gases. So alkane C1 to C4s are gases, C5 to C17s are liquid, and C10, 18 onwards wax. Okay, it becomes like a white solid. So the physical property. So the physical state when the C1 to C4s are gas, C5 to C17s are liquid, and then C18 onwards it becomes wax or solid. And then second, boiling points. So boiling point of alkanes are the lowest of all groups of organic compound. So the force of attraction among the alkanes are very weakest van der Waals attraction. That's the reason why among the isomeric, that is the reason why it get the lowest boiling point among all the organic compound. If I taken that isomeric alkane, so you have N-pentane, isopentane, and then neopentane. What is the structure of the compound? N-pentane means CH3, CH2, 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 CH3. Isopentane means CH3, CH, CH3, CH2, CH3. Neopentane means CH3, C, CH3, CH3, CH3. This is the neopentane. When you are having this isomeric compound, what will be the boiling point? So the boiling point of N-pentane is more than isopentane, which in turn more than neopentane. Why it will be? So when we are increasing the branching, the surface area is decreases, and then intermolecular bonds become weaker. That's the reason why when we are increasing branching, so the boiling point decreases. So the boiling point is directly proportional to molecular weight. Okay, and then the same thing, the boiling point is 1 by indirectly proportional to the chain for the isomer. Why? Because the surface area decreases. Okay, and then boiling point is directly proportional to van der Waals force of attraction. So if it is liquid, you are changing that boiling point. And then if it is a melting point, when you have the wax, you have the melting point, no? So the linear chain compound containing even number of carbon have higher melting point than the unbranched alkane. So what they are saying, you are taken N-pentane and then N-hexane. So you can write that pentane CH3, CH2, CH2, CH3. For hexane, CH2, 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 CH3. So you are starting 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Okay. So the methyl group, both the methyl groups are directed on the same side. Here, this methyl group and these methyl groups are opposite direction. So when the melting point of the even number of carbon having more than the odd number of carbon atom. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. So it will have the more. So the unbranched alkane contain even number of carbon atom have higher melting point than the unbranched alkane containing odd number of carbon atom. So that melting point is directly proportional to the molecular weight, which also directly proportional to packing efficiency. What is packing efficiency? When you have the molecule, you have to arrange like this. So whereas here means among these two, which will have the higher packing efficiency? First one or second one? This one or this one?
Second one, sir.
Among the two, which one have top one or bottom one? So this will have the higher boil. So because it has the packing efficiency. So since 1, 2, 3 groups steric entrance. Here 1, 2, 3, 4, 5, 6. ஒரே சைடு இந்த சைடு 3 இந்த சைடு 3 டிஸ்ட்ரிபியூட் ஆயிருக்கு. ஆனா இங்க பாருங்க, இங்க வந்துட்டு ஸ்டெரிக் என்ட்ரன்ஸ் கம்மியா இருக்கும். ஆனா மேல வரும்போது ஸ்டெரிக் என்ட்ரன்ஸ் ஜாஸ்தி இருக்கு. அதனால அதோட மெல்டிங் பாயிண்ட்டும் மாறுது. And then if you are going for the fuel capacity, so fuel capacity, decreasing order of fuel capacity is if you have more branching, it has more capacity than less branch, then linear low molecular weight, and then higher molecular weight. So this is the order. And then if you're seeing that solubility, insoluble in water. Wax தண்ணில கரையுமா? கரையாது. So that wax will be soluble in non-polar solvent, benzene, ether, chloroform, kerosene, அந்த மாதிரி இருக்கிறதுல கரையும். இதெல்லாம் கரையாது. Okay. When you are coming for the chemical properties, so what are the chemical properties? Number 1, so alkanes are chemically unreactive at ordinary temperature. So due to the presence of carbon hydrogen bond in the electrophilic nucleophile, because there is no electronegativity difference, not much electronegativity difference. So they cannot react with the at ordinary temperature. They do not have any affinity with your electrophile and nucleophile. So the electrophile nucleophile do not attack them, but they do not react with even with acid, base, and oxidizing agent. So, but these are the compound which readily react with halogen in the presence of light. Same way, they readily react with the HNO3 when heated. So how it will undergo? So it mainly undergo substitution reaction. It's mainly undergo substitution reaction. What is substitution reaction? These are the compound which you cannot, you can transfer one or two halogen at one or, so substitution means replacement of one by another. A group of atom or a atom which can replace one by another is known as substitution. As like in the playing, if you are having one number will be substituted. If any of the person get affected, so this person go and substitute. So in the cricket, you have the 12%, no? So 11 plus 1, that plus 1 is substitution. Same way that in the chemical reaction, any group which can be replaced by other group, then it is called substitution. Okay? Clear, ma? Yes. So first, halogenation. Alkanes react with halogen in presence of light. Okay? It will give alkyl halide plus HX. When you are seeing that reactivity order, tertiary reactivity become tertiary will undergo faster rate than secondary, which in turns more than primary. So the reactivity of halogen, when you are seeing that reactivity of halogen, so it becomes the order like fluorine can readily undergo then chlorine, which in turns then bromine, then iodine. So the fluorine can react even in the dark. Chlorine, bromine will require the light. This will undergo dark. This will undergo light. Iodine does not show any reaction at room temperature. On heating, it will undergo reaction. So generally, the fluorination reaction will be highly explosive because when the methane or, for example, methane when react with fluorine, it will give carbon plus hydrogen fluoride. The beauty of this reaction is the same thing. So the direct fluorination of alkane, when the methane react with the fluorine, it's explosive. Same reaction is successfully carried out by diluting fluorine with the nitrogen, carrying out the reaction in a metal tube packed copper cast at the temperature of 150 to 350 degree. The fluorination is usually complex mixture. So எப்படி வரும்னு பாத்தீங்கன்னா same fluorination heating 150 to 350 degrees centigrade, it will give CH3F plus hydrogen fluoride. Okay, this is the way you can give that. And then chlorination, it will undergo. How the reaction is happening? So it can be explained with the help of chlorination of methane or chlorination of ethane. So we will take the chlorination of methane. Methane reacted with chlorine in presence of light, it will give methyl chloride. When it reacts with chlorine, it will give dichloromethane. Again, it reacts with chlorine, it will be chloroform. Again, it reacts with chlorine, it will give carbon tetrachloride. So this chlorination can be takes place at 300 degree or 100 degree in the presence of organic peroxide and 150 degree in the presence of ethyl lead. So these are the way by which you can take the reaction at different temperature. How it will give methyl chloride. So what I say, methyl chloride, dichloromethane. இதெல்லாம் solvent, dichloromethane liquid. இது வந்து chloroform. உங்களுக்கு தெரியும் chloroform வந்து எதுக்கு யூஸ் பண்ணுவாங்க, anesthesiaவா யூஸ் பண்ணுவாங்க இல்லையா? And then carbon tetrachloride, it will be used in the fire extinguisher. how the reaction is happening, that we have to find out. So when you are seeing the mechanism of the reaction, initially it will take place chain initiation. It will undergo free radical mechanism. What is free radical mechanism? What is free radical? When the compound which will give a odd electronic species, then it is called free radical. So if the free radical mechanism always undergo with this step, chain initiation, chain propagation, and then chain termination. So this is the first step, this is the second step, this is the third step. In the step 1, what will happen? You are using the chlorine ClCl. In the presence of light, it will be homolytically cleaved into chlorine dot plus chlorine dot radical. And the step 2, what will happen? That Cl dot from the step 1, when it treat with the methane, this radical and this radical will combine. It gives HCl plus CH3 dot. So the same step, CH3 dot, when treated with chlorine, chlorine, so what will happen? CH3, Cl and Cl dot. It will give CH3Cl plus Cl dot. Idu vacha? Next, that Cl, that Cl dot, when react with, இப்போ மெத்தில் குளோரைடு இருக்கு இல்லையா, ஸோ ஒரு குளோரினோட சப்ஸ்டியூட் ஆயிடுது, ரிமைனிங் 3 ஹைட்ரஜன்ஸ் இருக்கு. இதோட போடும்போது இட் வில் கிவ் HCl plus CH2 dot and Cl. இப்போ என்ன ஆகும்? இந்த CH2 dot Cl again it will react, start reacted with Cl2 Cl2. So it will form homolytic fission. It will give Cl CH H Cl Cl. Now one more chlorine is coming. So what will happen? It will give HCl plus C dot Cl Cl and hydrogen. Correct? Again it will react with chlorine, chlorine. So what will happen? This CH3Cl, this one will undergo CCl3 and one nitrogen, CHCl3 one nitrogen. So finally it going to react with one more Cl dot. ஏன்னா இதுல HCl ஒரு Cl dot வந்துருது இல்லையா, அந்த Cl dot. இப்போ என்ன ஆகும்? It this one the Cl dot it will take and H dot will give. So C Cl 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 dot. Now when you have that Cl2, it gives C Cl 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 C plus Cl dot. So because of this chain reaction, look here, இங்க ஒரு Cl dot 1 2 3 4 பாருங்க. So first chlorine substituted and then second chlorine substituted, third chlorine substituted and fourth chlorine substituted. This is the way, sorry, this is the fourth chlorine substituted. So this will undergo, it will give Cl dot. So this is the way the reactions are undergoing. Okay, so this is called propagation. When you want to terminate this reaction, so you have to go for the third step, right? What is the third step? Chain termination. So when the termination going, the reaction will stop. Otherwise, it will not stop. How the termination will occur? For example, when you have the radical plus 2 radical is there, it will form a bond. Then it will become, reaction will be quenched. Or otherwise, the radical of 2 radical when combined, it will give ethane. Okay. Or otherwise, when you quench the 2 radical, it will give chlorine molecule. So by this way, you can terminate this reaction. So this is the normal mechanism of the halogenation of your alkanes. So iodine will give directly, and then bromine also will give directly. So next. Next, combustion. How combustion will occur? When you are treating methane in presence of oxygen, it will become carbon dioxide plus water plus 212.8 kilocalorie per mole. Okay. So the general combustion for any alkane is this is that. Okay. So incomplete combustion of alkane result in the formation of carbon block, which is used in the manufacture of ink, printer ink, block pigment, and as a filter. So for example, when you are treating, if it is undergo complete combustion, it will give you the carbon dioxide and water. Suppose if it is not under complete combustion, it will give carbon black, incomplete combustion. So that carbon black, we can use the printer ink, real ink, and then block pigments and filters. Okay. Generally, and the reaction when you have alkane CnH2n plus 2 plus 3n plus 1 of that divided by 2 of oxygen, that moles of oxygen, it gives n moles of carbon dioxide plus n plus 1 moles of water. This is the general combustion reaction. And then third reaction, thermal decomposition. So this thermal decomposition reaction, when you are taken alkane, for example, propane, when you are heating with the 675 to 875 Kelvin, it gives propene. Same way, when you are heating this with the it will give CH2, will give CH2 double one CH2 plus CH4. This will become ethene and methane. So this is known as pyrolysis. So you are breaking. Okay. Here first 2 hydrogen removed. Here it will break over here. So this is the way by which we can prepare that. And then isomerization. What is isomers? What is isomers? When the molecule have the same molecular formula and the different structural formula, it is called isomerization. So now we are going to see that isomerizations. Isomerization clearly. In the alkane, you have 2 types, chain and nuclear isomerism. Okay, that isomerism only it will exhibit. Position and all, when you have the functional group, that position will come. Then functional group isomerism also, it will be there. When you have different types of compound you are using, no, that time you will get. When you are using hydrocarbon, if it is hydrocarbon, you will not get that isomer. Only chain and nuclear isomerism you will get it. So for the isomerization, when you have taken N-butane, CH3, CH2, CH2, CH3, if you are treated with the AlCl3 in presence of hydrogen chloride and then heating, it will give CH3, CH, CH3 and CH3. So the N-butane become isobutane. This is called isomerization. Okay. And then the last reaction is aromatization. Aromatization. Aromatization, when you have N-hexane, 1, 2, 3, 4, 5, 6. This is called N-hexane. This N-hexane, you are treated with chromic acid, Cr2O3 or vanadium pentoxide or molybdenum oxide, heating and giving pressure, it will become benzene. So it's a very high reaction. It will convert it into benzene. Okay. Okay, ma. Any doubts?
No, sir.
And then alkenes. நான் இன்னைக்கு மெத்தட் ஆஃப் ப்ரிப்பரேஷன் ஃபுல்லா போறேன். நெக்ஸ்ட் கிளாஸ்ல மீத்தேன், ஈத்தேன், எத்திலின், அஸ்டிலின், பென்சின் இதோடைய ஹைபிரிடைசேஷனையும் ஐசோமரைசேஷன் தனி கிளாஸ்ல பார்ப்போம். ஓகே, டுடே we will complete the preparations of alkane, alkene, alkynes and physical and chemical properties of alkane, alkene and alkynes. Okay. So what is alkenes? So alkenes are these are the hydrocarbon which will possess carbon which will possess carbon double bond. It has the general formula CnH2n plus 2. So the name should end with ENE. The carbon double bonded carbon maximum it will be sp2 hybridization. Okay. Now when you are giving the name, so name should be, you have the alkane, you remove that ANE plus you add ENE, then it become alkene. So you are removing ANG. So it become ENE, alkenes. Okay. So it will show the isomerization. Alkene show the isomerization, chain isomerization, position isomerization, and then ring chain isomerization, you can end with isomerism, and then geometrical isomerism. Okay, so now we'll go the method of preparation. Number 1, partial hydrogenation. Partial hydrogenation. Partial hydrogenation of alkynes So partial hydrogenation of alkyne or partial reduction. Anything you can call reduction of alkynes. When you have the alkyne means carbon, carbon, triple bond, right? So you have the hydrogen and then R group. When you're treated with hydrogen, okay, so two types reduction you can do. When you are doing, you will get R, C, double bond C, R, hydrogen, hydrogen. Then C, double bond C, hydrogen, hydrogen, or look this, when the across the carbon carbon double bond, okay, two similar groups are present in each carbon atom on the double bond. If the two similar groups are in the same side, then it is called cis. If the two similar groups are in the opposite side, it is called trans. Please remember, when the two groups are where you across the carbon carbon double bond, the two similar groups on the same side, then it is called cis form. If the two groups are in the opposite side, then it is called the trans form. When you are taken the alkyne, if you are doing reduction with a suitable reduction, so this is called when you are doing Lindlar catalyst. What is Lindlar catalyst? Palladium, calcium carbonate, and then sulfur. This is called Lindlar catalyst. When you are doing the hydrogenation by using palladium, calcium carbonate, and sulfur, the Lindlar catalyst, you can able to get the cis alkene. The same thing if you are doing reduction with sodium in liquid ammonia, then this reduction is called Birch reduction. Birch reduction, you will get the trans as a product. Okay, clear? So for example, when you are treating CH3, C triple bond CH. So when you are doing reduction with hydrogen, okay, so what you will get? For example, C and CH3. 2 butane. When you are doing reduction with the Lindlar and then Birch. So through the Lindlar, you will get CH3, C double bond C, CH3, HH. That means 2 butane, but it forms this form. So when you are doing Birch reduction, you will get the 2 butane, no doubt about it, but it will be a trans form. Cis and trans having different melting and boiling points. So because they are geometrically different. So this is the one way, first method. And the second method, so the first method is two reaction potential. Second method, dehydrohalogenation of alkyl halide. Hydrohalogenation means HX. Dehydrohalogenation means minus HX. You have to remove the HX. So when you are taken that alkyl halide, suitable alkyl halide, the halogen and then the adjacent carbon having hydrogen. So this can be removed. Then it could yield as a C double bond C C C plus HX. When it will go? When you are using alkaline K potassium hydroxide and heating, it will give us a product. Example, you take CH3, CHBr, CH2, CH3. Now you have this hydrogen, here also hydrogen. When you are using that, you will get the two different products. Same alkaline, alcoholic KOH or alcoholic NaOH, anything you can use. A alcohol because it has to soluble. Okay, water soluble. Sodium hydroxide water dissolve. So alcohol water miscible. Adanale, you have to take the component alcohol, then you treat with sodium hydroxide. One thing, the first chance removal of this hydrogen, second chance removal of this hydrogen. So when you are removing the first chance, so what is the product? CH3, CH double bond, CH single bond CH3. So you will get butene, 2-butene as a product. When you are removing this CH3, CH2, CH double bond, CH2. So 1-butene. So this will be the major product. This will be the minor product. Okay. So this when you are considering this will be the alkyl group. This is the alpha position. This is the beta position. This is the beta dash position. So அதனால ஞாபகம் வச்சுங்க, எப்பவுமே ஃபங்க்ஷனல் குரூப் எதுன்னு ட்ரீட் பண்றோமோ அந்த ஃபங்க்ஷனல் குரூப் இருக்கிறதுக்கு பக்கத்துல இருக்கிற கார்பன் வந்து ஆல்பா கார்பன். இப்ப நம்ம புரோமின் தான் ஃபங்க்ஷனல் குரூப், தட்ஸ் வை இட் இஸ் ஆல்பா கார்பன். நெக்ஸ்ட் கார்பன் பீட்டா, தென் நெக்ஸ்ட் கார்பன் காமா. ஸோ அதே போல ஈக்குவலா இந்த சைடு இருந்ததுன்னா தென் இட் வில் பிகம் பீட்டா டேஷ். So if the hydrogen removed from the beta hydrogen, the halogen removed from your alkyl group, then it is called beta elimination. So this reaction is known as beta elimination. When you are beta elimination reaction is followed அப்படின்னு சொன்னா, so when you have tertiary alkyl halide readily undergo dehydrohalogenation, then secondary, which in turns of primary, then which in turns of methane. So you have the halogen group, right? When you have the halogen group, what are the halogen can easily leave? So the iodine can easily leave than the bromide, then it can easily leave than chloride. So this is the second dehydrohalogenation. And then third, suppose if you have vicinal halide. So what is the meaning of vicinal dihalide? So the halide can be vicinal and geminal. ரெண்டு meaning இருக்கு. Vicinalனா if the two adjacent carbon having the halogen, this is called vicinal. If the same carbon having the halogen, then it is called geminal. Is it clear, ma? Are able to understand what is the geminal, what is vicinal?
Yes, sir.
Okay. So when you take CH2Br and CH2Br, same like this vicinal halide you are taken. If you are treated with zinc and methanol and heat, you can get CH2 double bond CH2 plus ZnBr2 alkene. So this is also dehalogenation reaction. This is called dehalogenation. So suppose if you have R, CH, X CH2X. When you are treated with zinc, you will get RCH double bond CH2 plus X2. Sorry, Zn X2. So you tell me what is the product you will get when you are taken CH3 CHBr 1,2 dibromopropane you are treating with zinc. What is the product? Tell me what is the product? What is the product? What is the product you will get? Yes, just guess it.
BR.
Yes.
Sorry, CH3. CH double bond CH2, sir, plus zinc Br2, sir. Zinc Br2, sir.
Zinc bromide. So you will get the propene. Okay, good. Very good. And then the last reaction, dehydration of alcohol. So when you are doing the dehydration, so the reaction will become, so you have that hydrogen and hydroxyl will be in the opposite adjacent carbon. If you are using concentrated H2SO4 and then heating, it can be able to give the alkene. So the dehydration of alcohol in the presence of acid catalyst, it will give the alkane. So the condition same way, when you have the tertiary alcohol, it undergo faster rate than the secondary, which it turns primary alcohol. Okay. So tertiary alcohol is faster rate. So same way you have CH3, CH2, CH2OH. When you are treated with concentrated sulfuric acid, what is the product you will get, Pa? What is the product you will get? What is the product you will get? Will you get the product or not? Will you get the product or not?
Yes, sir. Yes, sir. We'll get the product, sir.
What?
Yes.
If it is wrong also, no problem. So
We'll just get only CH3, CH2, CH2, sir.
CH2
CH2, CH2, sir.
like this. Oh, this carbon valence is not filled. No, look here. There is hydroxyl and one of the hydrogen. When it goes, it will give CH3, CH double bond, CH2. That's all. So what is the mechanism I shown here? This is what no. So same way you can write CH3, CH, COH, H. When you have that, you remove this, it will create a double bond. Clear? Is it okay?
Clear, sir.
So dehydration of alcohol also it leads to the product formation. Now today I will teach you the Markovnikov and anti-Markovnikov rules up to. Okay, so tomorrow we are going to do many addition reactions. Okay, so what is Markovnikov? What is anti-Markovnikov? See, I am writing the alkenes CH3, CH double bond, CH single bond, CH6. So across the double bond, this is the double bond place. So when you are seeing the left hand side, you have the two carbon. Right hand side, you have the two carbon. Left hand side, you have the two carbon. Okay. Whereas if I am writing this same propene, CH2, butane, CH, double bond CH2. Here the double bond is there. Right hand side you are having one carbon, and the left hand side you are have the 3 carbons. So this is called unsymmetrical. This is called symmetrical. ஏதோ ஒரு பாயிண்ட்ல you are dividing the molecule into 2 equal half, then it is symmetrical. If it is same, and the 2 half வந்து சேமா இருக்குன்னு சொன்னா symmetrical. Suppose சேமா இல்ல அப்படின்னு சொன்னா then it is called unsymmetrical. So alkanes பொறுத்த வரைக்கும், if it is a symmetrical alkanes, when it undergo reactions, it will give same type of product. Suppose if you have the unsymmetrical alkanes, when it undergo reaction, we will get the 2 different products. For example, you are having R, CH, double bond CH2. When you are treating alkyl, okay, the unsymmetrical ketone, you are treating with HBr, hydrogen bromide. Okay, that hydrogen bromide, when undergo reaction with hydrogen bromide, it gives 2 different products. One will be R, CH, single bond CH2. Then you can have the H, Br. HBr. Okay, so the HBr becomes H plus and Br. So the Br is added over here, and the H is added over here. So when you are writing, it become R, CHBr, CH3. The same reaction, suppose bromine is added that side, R, CH and CH2, R, CH2, CH2, Br. So hydrogen, then bromine. We will get this. So for example, you write ethylene, CH2, double bond CH2. ஒரு முறை என்ன செய்றோம், இதை கிளீவ் பண்ணிட்டு இங்க ஹைட்ரஜன் இங்க புரோமின் போடுறோம். அப்ப என்ன ப்ராடக்ட் கிடைக்குது, CH3, CH2, Br கிடைக்குது. அதே என்ன பண்றோம், மேல கிளீவ் பண்ணிட்டு இங்க புரோமின் போடுறோம், இங்க ஹைட்ரஜன் போடுறோம். சோ அப்ப என்ன ப்ராடக்ட் கிடைக்கும், CH2, Br, CH3. சோ நேமிங் கொடுக்கும்போது எப்படி கொடுப்போம், நம்ம 1 2 1 2. சோ அப்ப என்னது, எத்தில் புரோமைட், இங்க என்னது, எத்தில் புரோமைட். சோ ரெண்டு பக்கமும் ரெண்டும் ஒரே ப்ராடக்ட் தான். சோ when you are using symmetrical alkane, you will get the same. பட் இங்க பாருங்க, இங்க கொடுக்கும்போது 1 2 2 bromo product, இங்க வரும்போது 1 bromo product. So these are 2 different products. So one will be according to Markovnikov rule, another one will be according to anti-Markovnikov rule. So tomorrow we will discuss about the Markovnikov and anti-Markovnikov, and then alkynes, and then carbon. Okay, so what is that, aromatic hydrocarbon. We will discuss tomorrow. Okay, shall we wind up?
Okay, sir. Thank you, sir.
Okay. Thank you, sir. Okay, thank you. Welcome. Only one participant.